Number one, what is AI? Artificial intelligence, AI, refers to the simulation of human intelligence in machines that are programmed to think and act like humans. This encompasses abilities like learning, reasoning, problem solving, perception, and language understanding. Types of AI. Narrow, weak AI, designed for specific tasks, like Siri recommendation systems. Most current AI falls into this category. General, strong AI, hypothetical AI with human-level intelligence across diverse tasks. No current example exists. Key components. Machine learning enables computers to learn from data without explicit programming. Deep learning, a subfield of machine language using artificial neural networks with multiple layers. Natural language processing focuses on enabling computers to understand and generate human language. Number two, early momentum. The concept of AI emerged in the mid-20th century, with key milestones and periods of both excitement and setbacks. AI winters. Early concepts and foundational research. The Dartmouth Workshop, 1956, is considered the birth of AI as a field. Key milestones. ELIZA, 1966. Early NLP programs simulating a psychotherapist. Expert systems, 1970s. Programs mimicking human experts in specific domains. AI winters. Periods of reduced funding and interest due to unfulfilled expectations. Number three, the current AI influx. Several factors have fueled the recent surge in AI. Big data. Massive data availability provides fuel for machine learning. Increased computing power. Advances in hardware, especially GPU, enable training complex AI models. Improved algorithms. More efficient algorithms enhance AI performance. AI in everyday life. Healthcare. Diagnosis, drug discovery, personalized medicine. Finance. Fraud detection, risk assessment, algorithmic trading. Transportation. Self-driving cars, traffic optimization. Entertainment. Recommendations, content creation. Generative AI and large language models. AI capable of creating new content, text, images, etc. LLMs like Gemini, ChatGPT, and Bard demonstrate advanced language understanding and generation. Number four, benefits and applications. AI offers numerous advantages across various sectors. Automation and efficiency. Automating repetitive tasks, freeing human workers. Improved decision-making. Analyzing large data sets for insights and better decisions. Personalization. Tailoring recommendations and services to individual users. Scientific discovery. Accelerating research in various fields through data analysis and simulations. Number five, misuse of AI. AI also presents potential risks. Bias and discrimination. AI systems can perpetuate biases present in data. Privacy concerns. Data collection and processing raises privacy issues. Job displacement. Automation may lead to job losses in certain industries. Misinformation and manipulation. AI can be used to create deepfakes and spread false information. Autonomous weapons. Ethical concerns regarding AI-powered weapons systems. Number 6. Regulations and control. Regulating AI is complex and requires balancing innovation with responsible use. Current regulatory landscape. Various countries are developing AI regulations, such as the EU AI Act. Ethical guidelines. Organizations are establishing ethical principles for AI development. Challenges in regulation. The rapid pace of AI development makes regulation difficult. Balancing innovation and control. Finding the right balance between fostering innovation and preventing misuse. Concerns about overregulation. Potential for overly strict regulations to stifle progress. Number 7. The future of AI and quantum computing. Predicting the future is difficult, but key trends and the convergence with quantum computing are important to consider. Future expectations of AI. Continued advancement in deep learning, explainable AI, edge and decentralized AI. Increased use of AI in scientific discovery. The metaverse and human-AI collaboration. Growing emphasis on ethical and responsible AI development. Quantum computing and its impact on AI. What is quantum computing? Uses qubits, which can exist in superpositions, allowing for exponentially faster calculations for certain problems. How quantum computing can enhance AI. Faster training of AI models. Solving optimization problems. Developing new AI algorithms. And the rise of quantum machine learning. Current status and challenges. Quantum computing is still in early stages, with building stable computers being a major challenge. Google's recent breakthrough. Google has made significant progress in reducing error rates in its quantum processors, a crucial step toward fault-tolerant quantum computers. This enhances the reliability and duration of quantum computations. Potential applications of quantum AI, drug discovery, materials science, financial modeling, cryptography, logistics optimization, and enhanced AI algorithms. The synergy of AI and quantum computing. The combination offers a potential for breakthroughs by providing the computational power for complex AI models. While AI can develop new quantum algorithms and optimize quantum hardware. Stay safe, stay secure, and if you haven't started to use AI, what are you waiting for? If used correctly, it can enhance your life. I'll see you again soon. Bye-bye, and thanks for reading, watching, and listening.